Alright guys, what's up? How you doing? Here's a chemistry question for you guys. So the question says, what weight of sodium hydroxide is required to make 500 cm cube of a 0.2 molar solution? So here you are given the atomic masses of each of the constituent elements: sodium 23, oxygen 16, and then hydrogen 1. So here are the options: 40, 20, 10, 4, 2. So let's look at how we're going to solve this question. It's very easy. Very easy. Let's check it out. So as you can see here, this is actually a question on stoichiometry. Of course, you know that already because stoichiometry is a chemistry of calculations. So you should already know that we're going to calculate in this question, and there are some important formulas that you need to know if you will be able to solve questions on stoichiometry and other questions on stoichiometry generally. So these formulas are as follows. The first one is mole is equals to what? Mass over molar mass. Please note that. And your mass should be in gram, while your molar mass is in gram per mole. These are the units that we use for easy calculation, and they are the standard units we use when calculating in stoichiometry. Yeah. Number two is that mole is equals to concentration times volume. This is when you are dealing with solution. Concentration times volume. Concentration is in mole per dm cube, and mole per dm cube is the same as molar. While the V is the volume, and volume is in dm cube, which is the same as liters. So the next is mole equals to volume at STP. This is talking about gas now. The volume at STP divided, that STP means standard temperature and pressure. So divided by 22.4 dm cube or 22,400, that's the conversion. And then the fourth one is that mole is equals to the number of particles divided by 6.02 times 10 raised by 23 per mole. This value that you're seeing here is actually what we call the Avogadro's constant. Yeah, it's actually what we call the Avogadro's constant, 6.02, and then the NP means the number of particles. So this can be the number of atoms, it can be the number of molecules, it can be the number of electrons, just number of particles in that particular substance. You understand me now? So now, how do we now solve stoichiometric questions? The first thing is that you write out the parameters, and these are what we are going to follow in solving the questions that we have in this video. So first thing is that you write out the parameters provided in the question. Then you ensure the parameters are in what appropriate units. So the mass should be in gram, like I said earlier. Your molar mass should be in gram per mole. The volume should be dm cube or liters, and then the concentration should be mole per dm cube, which of course is also the same thing as molar, capital letter M, which was given in the question. So the second thing you have to do is that based on the parameters you're given, you look out for the formula that will be used in solving that particular question based on the list of the four major formulas I gave you earlier. Then the third thing you do is that you play around the formula that you already have. So let's try that out now. Just know these three things, these three major steps that I just write out now. Note them and let's try them out. So now this is the question. Yeah, this is just a note of caution just for you to know that sodium hydroxide is written as NaOH. Sodium is Na, then hydroxide is OH minus. They come together, and then we have NaOH. So how do we do that now? So the step one, the volume is there. The volume is 500 cm cube, and note that your volume has to be in what? In dm cube. So when you're not giving a volume in dm cube, you have to change it to dm cube because it has to tally with other units. Remember, your concentration is mole per dm cube, so it won't give you the right value, the correct answer when you are using your volume as cm cube and then your concentration is in dm cube. I don't know if you get that right. So you have to convert your volume to what? To dm cube, and that's what we all just did here. And to convert from cm cube to dm cube, you simply divide by what? By 1000. So these are the parameters we are given. And then for the molar mass of sodium hydroxide, what you simply do is that you add the masses of each of the atoms in this particular compound. So each of the atomic masses are being added together to give us what? The molar mass of the molecule of the substance. So onto the step 2, we are now looking for the formula. Remember, we already written out the parameters. Now, based on these parameters that we have the volume, the concentration, and the molar mass. So we are looking for the formula that we can play around to get the answer to this question. Remember, we are looking for the weight of sodium hydroxide that will be required to make that particular solution. So the weight is also the same as the mass, of course, you know that. So we are looking for the mass. So yeah, we've gotten the two formula we'll be learning, and that is mass over molar mass. Mole is equals to mass over molar mass, and mole is equals to concentration times volume. So in this case, we can equate mass over molar mass equals to concentration times volume, of course, and then lead us to the third step. Let's play around the formula. So after equating this, you do normal mathematics, cross multiply, your mass equals to the concentration times volume times the molar mass, and then inserting your parameters, you multiply them together, and then your mass is equals to 4 grams, 0.2 multiplied by 0.5, which is the volume, multiplied by 40, which is the molar mass. Then we have a mass to be what? To be 4 grams, and that is the answer right there. So let me give you this question. If truly you've gotten what we did in this video, solve this question yourself. Yeah, drop your answer in the comment section. Thank you for watching this video. I hope you learned something. If you learned something, like the video and subscribe to the channel. Yeah, bye.